so for this lesson, we're going to talk about parallel and perpendicular lines. Parallel lines are two lines in the same plane that never intersect. So we want you to graph these two lines on the same grid. So we're going to actually color code these things. My first line I'm going to graph in red, and I'm going to begin down at -3. Again, we got a problem here because I'm not calibrated. I'm going to go up 2 and over 1, up 2 and over 1, and I'm going to draw that line. The next line I'm going to graph in green, and I need to actually add 6x to both sides. 3y equals 6x plus 12. Divide 3, divide 3, divide 3. Y equals 2x plus 4. So here I'm going to start beginning at the y-intercept at 4, and I'm going to go up 2 over 1, down 2 left 1, and there's a graph of two parallel lines. So we know that these lines are parallel. I mean, that was kind of the whole point for us drawing these things. But what do you notice about their slopes? And if you take a look at the slopes, the numbers attached to the m, this slope was 2, this slope was 2. So you've just found out something very important, is that the slopes of parallel lines happen to be the same. So I'm going to see if I can extend this up a little bit. It doesn't want me to do it. Come on, go up. All right, well, forget it. It's not going up. But what you notice about the slopes is they are the same. And you've learned something very important right now. And that thing that you just learned is that parallel lines, there we go, is that parallel lines have the same slopes. We need to add to this, though. They have the same slopes, but different y-intercepts. And that's really important, because if they've got the same slopes and the same y-intercepts, then they're going to be the same line and they wouldn't be parallel. Okay? So there you go for the parallel lines. Same slopes, different y-intercepts. Well, perpendicular lines happen to be two lines that intersect to form right angles. So two lines that intersect to form right angles. Hopefully you remember that right angles are 90-degree angles. Okay, so if we graph these two lines, I'm going to color code them again. You need to label these things or color code them or do something. When I graph this line, I'm going to begin at -5, and I'm going to go up 1 and over 2, up 1 and over 2, and there's my line in red. For my line in green, I need to manipulate this a little bit and get y equals -2x plus 3. So now here I'm going to begin at 3, and I'm going to go down 2 over 1, down 2 over 1, and there's my green line. And if we pull out a protractor, probably yours would be better than mine, you could measure those angles to be 90 degrees. So these lines are perpendicular. By the way, a symbol for perpendicular looks like that, an upside down T. Especially when you get into geometry, you're going to definitely need to know that. Well, what do you notice about these slopes? Well, they are different. Without a doubt, they are different. This slope here was 1/2. This slope here was -2. So they're not just different. Well, I guess the question is, how are they different? And they're different in a very particular way. So if we were to look at these slopes and we compared 1 over 2 to -2, if I wrote -2 as a fraction, it'd be -2 over 1. Hopefully you notice that these are reciprocals, but more than just reciprocals, they're negative reciprocals. Whatever fraction you get, you've got to change that sign and flip it over to get the negative reciprocal. So perpendicular lines have negative reciprocal slopes. And again, I guess an example of how to know whether something's a negative reciprocal slope or not. Negative reciprocals would look like this. If you had a fraction that was a over b, the negative reciprocal is negative b over a. Or maybe you started out with a fraction that was negative to begin with. Maybe your fraction was negative a over b. Your negative reciprocal will be positive b over a. So you've got to actually change the fraction to make it its reciprocal, and you've got to negate whatever sign you started out with. Okay, so I think that is the end, and then the rest of it is just, is it this the end of it? Hold on. Okay, nope, so we got some examples. So determine algebraically if these two lines are parallel, perpendicular, or neither. Well, if they're parallel lines, they've got the same slopes. If they're perpendicular, they're negative reciprocals. And if the slopes have nothing in common, it's neither. So line 1, y equals 3x plus 2. Your slope is just 3. Line 2, 2y minus 6x equals 3. Solve this thing for y equals, add 6x to both sides. 2y equals 6x plus 3. Divide 2, divide 2. Y equals 3x plus 3 halves. Well, let's take a look at our slopes. Let's see. Positive 3, positive 3. These are the same slopes. Their y-intercepts are different because this y-intercept is a plus 3 halves. This y-intercept is a plus 2. So these guys are definitely parallel. That's our answer. Let's try one more. Let's put these guys into y equals and look at their slopes. The first line, 6x plus 3y equal to 8, minus 6x minus 6x. 3y equals negative 6x plus 8. Divide 3, divide 3. Y equals negative 2x plus 8 thirds. Let's take line 2. Y equals negative 2 thirds x plus 1. Oh, we already are in their slope thing. So this is interesting. When you look at the slopes, not really interesting. Oh, boy. When you look at the slopes here, this slope is negative 2 thirds. This slope is negative 2. Well, they are clearly not the same. They are definitely not negative reciprocals. So they're not parallel. They're not perpendicular. These lines just intersect, but in no special way. All right, so there you go. You should be going with your homework.